So it's 24 minutes past the hour, so I think we will start the session. So once again, welcome to Parallel Session C, Paper and Chemicals. As I said, my name is Graham Ormondroyd from Bangor University in North Wales, and I'm lead on the paper work stream, and I will be chairing the session. Just to remind you of house rules, please, if you can keep your microphones and cameras off if you're not presenting. Please do put questions into the chat box, and I will pick them up for the final question and answer session. And as you've heard, just to remind you that this session is being recorded. So really, you don't want to hear from me today. You want to hear from our fantastic speakers. We have two of our Transfire project partners with us today. And the first of those project partners is Mark Broomfield from Kimberly-Clark Corporation, one of our paper partners. And I'd ask Mark to present his work. Thank you.
Thank you, Graham. Afternoon, everybody. My name is Mark Broomfield. I work on the environment and sustainability team for Kimberly-Clark. Next slide. Okay, just give you a quick flavour of the paper sector in the UK first. So as an industry, there are around 47 paper mills in the UK, turnover of approximately 12 billion a year. We employ 65,000 employees directly, and then there's a significant amount of indirect employees as well. Make around 4 million tons of product that's spread across a variety of different grades, such as packaging, board, graphic paper, newsprint, tissue, and speciality grades. Interestingly, in the UK, we actually import 6 million tons of products per year, which makes the UK one of the biggest, if not the biggest, importer of paper products. And around 70% of the UK paper is actually made from recycled fibre. The vision for the UK paper sector, to become a trusted leader in the bio-based economy. So a trusted leader is customers and consumers valuing what we're doing, our role in the economy and our role in society. Utilising renewable raw materials originating from sustainable sources, key to the paper industry. You know, we're known for a fibre forest-based industry, so having that renewable, sustainable source is vital. Continuing to manufacture recyclable products. Localized production, we've heard this quite a few times already, but localized production based on best available technique, minimizing water loss and waste generation. The industry becomes a magnet for highly skilled workers. And business partners in the truly broad sense of the meaning there. That's businesses willing to invest in UK paper, that's the local community, that's local companies, that's other industries, that's the Transfire industries. You know, imagine the future business parks where we've got cement, chemical, paper, etc., all on the same part, all interacting with each other. And lastly, decarbonising. It goes without saying, really, decarbonising to reach climate neutrality. But with the power of the pen, I've pushed that to 2040 rather than 2050. And to be honest, I don't think our customers and our consumers are going to allow us to continue to say 2050 unless we've got a firm plan to achieve it, rather than a vague statement of ambition. Next slide. So the reality. In the days when those of you can remember when we used to be allowed to do school visits at our sites, I always remember one of the first reaction you'd get from showing pupils around when they went into that machine hall was, wow, it's a big, noisy, smelly, hot machine. And it's true, and therein lies a lot of the issues that we face. They're very capital intensive machines, the bigger ones costing well over 300 million. Investment, long asset life, at least 30-year asset life. We've got, although there are new machines in the UK, we have got an aging infrastructure in the UK. Very large machines. Now, some of these are the length of a football pitch, if not longer. and paper widths from 3 meters up to 7, 8, 9 meters wide. Highly energy intensive. We use a lot of heat and power in the process. Generate a fair amount of manufacturing waste, particularly for those mills recycling fibre, and large volumes of low temperature waste heat to air and also water. We are a major user of water industry, but I put borrower in there because the majority of the water, at least 80%, actually gets returned back to the environment, and often in a better condition than we abstracted it in the first place. So although we're a user, we do have a lot to share and learning opportunities on how we process and clean up those water sources. In the UK, we do generally have an aging workforce in the paper industry, so that's one of our challenges. And lastly, goes particularly for paper, competition from imports. So particularly where we've got countries operating without the same regulatory pressures with us, with lower cost pressures than us, there is a real effect from competition. And then lastly, just on the research, so where do we need to focus? So what research and innovations to accelerate the implementation of? I mentioned the waste heat before. There's a big opportunity around heat recovery, air, water, lots of high volumes of heat being lost from the paper industry. Looking at alternative and sustainable sources of fibre. Decarbonising the industry. There's a whole section on here we could write under decarbonisation, but the one in particular, I think, for the paper industry is around the heat. So we use a lot of heat for drying. We're essentially taking a wet slurry and drying it to a paper product. It takes a lot of heat, even after the mechanical dewatering. Valorization of the manufacturing waste stream. So how do we get more value from the waste streams? Can we partner with other industries, other transfer industries, to take those wastes so that they become a resource? And vice versa for us as well. Can we take other industry waste streams and use those to make our products? Embrace digitalization and the Internet of Things. I mean, I think digitalization and the Internet was seen as a threat to the paper industry, and it has had an impact. But I also think there's a lot of opportunity in here to embrace that and use that going forward. And the last point on here, focusing on research, reducing the environmental impact of current assets and a sustainable roadmap for future assets. And on that, it's almost a two-pronged strategy. So we have an aging infrastructure that we can't completely change overnight. So we need to have a roadmap for what we're doing with the current infrastructure, but also think what do we need to do in the future with the new machines, the new opportunities, and embrace both of those and not just focus on the current assets that we've got. Okay, short and sweet. Thank you very much.
Thank you very much, Mark. That certainly gives myself and the team some challenges for the next period of this project. So moving on from Mark, I'd like to introduce James Marshall from Fiberite, who has some interesting prospects already for the valorization of fibre and some of the paper industry waste. James?
Yes, thanks, Graham. Hopefully you can hear me. I'm unable to put my camera on. It's blocked. So at some point, if that can be cleared, that'd be great. But I'll start. So if you could move on to the first slide, please. Thank you. Oh, if you go back one. At Fiberite, we have the ambition to achieve the end of waste. Our motto, don't burn it, don't bury it, use it, alludes to the fact that there are many resources in waste which are currently being lost via landfill or incineration. As a society, we should be recovering and reusing these so we can deliver a true circular economy. There we go. So I've got my picture now. And as Paul Booth said on the previous session, that not looking at waste, but looking at it as a resource, a source of resources where we sit in the space. And there are a lot of resources in the household waste material that we can collect. So if you can move on to the next slide, please. This slide and the following one are actually build slides, which I probably shouldn't have done. So I thought I'd be driving the slide deck myself. So if you'd like to just click through till you get to a graph in the bottom right, and I'll just talk through. But what I'm doing here is trying to paint a bit of the scene on the waste challenge and the challenges affecting the sector by utilising some recent industry press headlines that are driving the different, highlighting the different drivers. So things like climate change, obviously energy from waste emissions is a big focus on that at the moment. Not picking on Lancaster, but it's an example of an individual local authority driver. Then we've got two examples of the impact of COVID on both service, which is very high profile. If your bins don't get emptied, then you see it. But what's less seen is the impact that COVID has had on the quality of the material that is being collected. And then the bottom one there is not necessarily a trend as such, that's a bit strong, but that some local authorities are looking now at trying to buy a bit of time. In some instances, it's to put a shorter term contract in, allow other innovative technologies like Fiberite, for example, to come through to give them alternatives. Because at the moment, top right, all you can see there, the only alternative is to burn more, which is counterintuitive to the requirements to achieve higher recycling rates. The graph there is just showing where we are at the moment. Left-hand side is stagnated roughly at 45%. And the right-hand side are where the EU targets are requiring us to get to. And Fiberite can sit there in the middle and achieve up to 80% of what is being pulled through based on the quality of the feedstock that we get our hands on. So next slide, please. And again, this is showing a bit of the pull. If you just jump through till you get a title across the bottom, that'll be great. So public and private pressure has led to governments introducing new legislation. And again, these headlines from recent press show where some of those drivers are. Thank you, that's a stop there. So we have a couple of headlines of brand owners showing a demand and a need for sustainable product and changing their design. We've got fluctuating availabilities in paper and plastics and that recovered resource material. We have stricter export rules, quite rightly. First China and then more recently Turkey have closed their doors effectively on some grades of contaminated materials and contaminated plastics. Effectively, we need to deal with our own materials here. Then you've got the plastic tax, you've got the extended producer responsibility schemes, you've got the deposit return schemes, all good ideas and good schemes that will be implemented over time. And finally, this bottom one, which I added this morning, is a pretty powerful headline from END's report last week, that to meet some of these demands, there's a fear that there's going to be a shortage of feedstock and resources. And as just to reiterate, you can't meet any of these requirements if you've not got your hands on the resources first off. So how do we deal with it? So next slide, please. Traditional recycling practices have used dry sorting and have done so for many, many years. Subsequently, the existing infrastructure can struggle to process wet, contaminated materials, such as when there's too much free liquid in bottles or there's wet fiber present in the material or food contamination. And the pandemic has heavily affected this cross-contamination situation and makes a lot of the rejected material or the missed material in the existing infrastructure a higher volume. So what we do at Fiberite is we turn this concept on its head by using an innovative water-based sorting system called hydrocyclo. The use of the water allows us to wash the food waste contamination from the other materials in the mixed stream, and therefore these materials or resources can then be recovered on site using various integrated unit operations. If you could click, please, it'll bring up, there we go. The key streams that we are able to recover are the plastics, which are both rigid and flexible, and I'll come on to that a little bit in a moment. The paper and card as a clean pulp. The food waste, if present, is washed out, and then that gives us some other commodity recyclables, such as the metals, glass, and PET. These recovered resources are then used, as I said before, to act as feedstocks to integrated bolt-on technologies, which can then produce a myriad of products, including high-value plastics, fuels, chemicals, and, if required, energy. Next slide, please. Sorry, and one more, I forgot to ask you to click. There we go. So our current R&D focuses on the valuation of two key resources. If you click, the pulp fiber from the paper and card, which includes pizza boxes, coffee cups, labels, and the plastics. So both rigid, which would be bottles, pots, tubs, trays, including black plastics. And that's an important point to note, that our process is color agnostic compared to, say, NIR sorting, which will leave the black or the dark plastics to run through. And the flexibles, which are carry bags, pouches, film labels, and a lot of wet wipes at the moment. If you click again, please. As we have derived these resources from waste, the materials are associated with inherent carbon savings, which is important. And I'll come on to that in a bit more detail on the next slide. And by using these materials as feedstocks in manufacturing, we can pass these carbon savings on to the product and chemical manufacturers, which helps the entire supply chain move closer toward achieving net zero. Next slide, please. So before I move on to talking about the products, I just wanted to touch on some sustainability. This is a work in progress. We're using a consultancy company called LCA Works to help build these impacts on our sustainability and CO2 footprint. But on the left, we have the greenhouse gas emission data based on processing RDF, which is refuse derived fuel. And if this waste was processed in a business as usual manner, which is domestic or export waste to energy, it would be on average about 420 kilos of CO2 equivalent per tonne of waste processed. If, however, it is processed through the hydrocyclo, we avoid the carbon dioxide emissions to the tune of 380 kilos of CO2 equivalent per tonne of waste. Further to this, and as mentioned before, each of the products we produce have an inherent carbon saving, which can then be passed on to the offtake manufacturers or end users. So, for example, each tonne of paper and card pulp we produce has a carbon saving of 640 kilos of CO2. If that is then used in manufacture a product, then the total carbon footprint of that product will be reduced and the carbon saving afforded by our pulp. Therefore, we are really helping to reduce the carbon footprint across the entire supply chain. Next slide, please. So, feedstock. Our process is flexible and adaptable, which it needs to be when it's dealing with waste. So we are able to process mixed residual waste, which is your household or workplace black bins, plus mixed materials that are rejected or missed by the existing infrastructure, which are the municipal recycling facilities. Also, with the aforementioned lack of export opportunities for things like contaminated MERV films and rigid plastics, we are also able to provide domestic processing for those. So there is no set feedstock that we can't handle, and we can take residual waste with a range of paper, plastic or food content. And we've noticed some interesting facts on some of the reporting that's being in place from some of the waste providers, and that is a difference in the actual compositions that are being put through, which is not done for any nefarious reasons, just the limitations that the existing manual classification structure for MERV code of practices can. So, for example, we've received material that was specified as having 90% plastic, 10% fines. When we put 136 tonnes of that through our plant, we actually recovered, as the graph shows there, a whole range of paper, flexible, rigid, metals, all of which we can uplift and present to disposal up to processing facilities. So it's a rich seam of resource that we can tap into. It's important to note that this material, with that mix of contaminants in it, even though the resource is to us, if that had gone for export, then it could have caused some issues with non-compliance. And secondly, with the current route for that, which is to domestic incineration, the focus on reducing the calorific value at some of the incinerators, which is caused by plastics mainly, and the carbon emissions that those same plastics cause for the back end of those plants, pulling those out and dealing with them as a resource and uplifting them to supply the chemical and manufacturing markets is the right way to go. So I'll go on to a little bit of the product pathways, which is the next stage, please, Graham, the next slide. What we've tried to do over the last few years is build a research and development and therefore a demonstration facility and now a commercial facility based on a robust series of product pathways. So it covers both plastics and paper. It enables us to absorb fluctuations in the varying feedstock. It allows for multiple offtake options so that we're never too reliant on a single product or a single market, single sector, or a single off-taker. Some of the comments made on the previous session were looking at where the end of waste, I beg your pardon, line can be drawn. And we spent quite a bit of time working with consultants and other interested parties to see whether we can create an end of waste product integrated in our plant, or we work with off-takers and manufacturers who have the relevant license and waste acceptance criteria to be able to create an end of waste at their plant. But the flexibility is key, moving with the legislation and changes in behaviours and the unprecedented situation brought upon by the pandemic. And it's important to note that the material and the packaging that we recover is new post-consumer material that is then presented to the circular economy. So next slide, and these are two slides just covering a bit of the value potential, and the figures being used here are not to be taken as read. These are examples just to show the steps that could be achievable and to show how much value and residual value is available in waste if you treat it right and you have the technology to recover. So first of all, looking at the pulp to sugar, we have developed a tiered approach, and that is to use a patented technology where we can hydrolyze the pulp using enzymes and convert that pulp into sugar. That sugar can be used as a building block to access the higher value chemicals market, such as fuels and some, as I said, some high value chemicals. Our process achieves economically viable sugar production and high conversion rates of the fiber. And I'll mention a little bit more about the sugar pathway in another slide. As an aside, the lignin-rich byproduct from hydrolysis can be used as a solid fuel and is being tested within adhesive and grout applications, thus making use of the entire pulp stream. Next slide is something similar on the plastics, where we're using bolt-ons to uplift what is a very problematic stream within the waste, and it's a high profile. There's a lot of programs, plastic in the ocean, etc., that we can try and do our bit on recovering and uplifting that material where we can. So again, don't read too much into the figures, but it's to show the step that can be required with integrated processing. So our hydrocyclo plastics can meet several pyrolysis specifications at a cost-effective rate, allowing for oils and waxes to be produced. It's important to note that although oils and waxes are a mid-value product, they can go into high-volume markets. So the outputs from several fiberite plants can be used to access that route without leading to market saturation, always making sure that we've got the pull. We're also running trials with some other innovative purification technologies, which will be integrated on site to further purify the film into an LDPE fraction, and then we can look to target the blow molding market, the packaging market, and deliver a post-consumer resin, which will be a full circular economy. And to remember, this is all material and resources that would have been lost to disposal. Next slide, please. VAMOS stands for value-added materials from organic silent waste sugar. And this is to techno-economically validate our process and prove out the concept described in the previous pulp slide. We have been successful in obtaining bio-based industries funding from Horizon 2020. So this project has partners from 5 countries and is being used to demonstrate and validate the pulp to sugar pathway with fibrite producing tonnage quantities of platform sugars at our facility in South Wales from the recovered waste derived pulp. These sugars, as mentioned before, then being tested as an ingredient in thermoset resin products, which is used to bind insulation fibers, and also as a fermentation feedstock for the production of lactic acid and a subsequent bioplastic product, PLA. The last picture there, bottom right on this slide, is a bioplastic fiber composite, also being developed within the project. And that particular picture is of a material being developed for use as a window frame product. Next slide, please. As mentioned, we're running our demonstration facility at a site in South Wales. This is an ex-aluminium smelting plant. You see a few pictures there, which has high eave height and plenty of power. So it's ideal for our current and expansion needs. But importantly, it also allows for partner technologies to be trialed and integrated on site. So the core fiberite process, separation process is up and running, and we are looking to install some further added value uplift technology and plants in the coming months. And we will also complete on the commissioning of the VAMOS facility. So that's where we are, that's where we're going. The last slide, please, is just to conclude that the platform enables mixed residual waste to be separated into pure pulp and polymer fractions. suitable for UK manufacturing. It provides a platform for the true post-consumer circular economy, and it provides new resources into the circular economy. So please head to our website and have a look at what we're doing, and thanks for listening.
Perfect, brilliant. Thank you, James. That was really, really quite inspirational. Thank you. Okay, we'll move forward straight away to another of our Transfire project partners. And that's Melanie Jury from Mitsubishi Chemicals. So take it away, Melanie.
Hi, I apologise. I had to dip out due to the natural gas price rises and how we're going to run our business. So I've just popped back in again. So a little bit about me. I'm Melanie Jury. I'm the president of Mitsubishi Chemical UK. So a chemical engineer by background, and I run one of the largest, most hazardous chemical sites in the UK, up on Teesside. So we make methyl methacrylate, and we start with natural gas, ammonia, acetone, methanol. We make various intermediates, and then finally make methyl methacrylate, which then goes on to make acrylic, which goes into paints and plastics. Next slide, please. Okay, I think I probably would want to challenge some of the comments that I've and sort of sense of where we think the foundation industry is, and particularly the chemical industry. I've been in the chemical industry now for over 30 years. The modernization I've seen in terms of the way we operate environmentally. We always were safety pioneers, and that's continued. And the diversity of our workforce and the quality of jobs that we have within our industry are really fantastic. And I think I would probably, we'll come onto it later, but sort of the challenge around particularly educators in terms of understanding of what we do in our industry. So to put it in context, on our site, over 30% of our workforce is under 30. So in terms of the chemical industry, I've stolen a slide here from the Climate Change Committee, but you can see how much reduction there's been in electricity supply, but also in manufacturing and construction. In terms of greenhouse gas emissions, you can see the effect of the pandemic on surface transport and aviation. But you can see really that the major greenhouse gas emissions are surface transport and buildings. The chemical sector still has a huge amount to do, and it's done, I would say, some of the easier stuff. It gets more and more complicated. And the foundation industry, particularly, I'm in the chemical industry, we make products that contribute to making our lives safer, healthier, and more productive. Next slide, please. Okay, so I didn't quite know what people wanted to understand. There's a couple of pictures of the site that I work on the right-hand side from different angles. In terms of our approach in the chemical industry, our job is to provide solutions, so chemical solutions that continue to decrease greenhouse gas emissions. So in the products that we provide, they have done an enormous amount to reduce greenhouse gas emissions, from lighter components in cars to the components that are used in wind turbines, etc. Our aim is to transition to net zero production, and for us that's quite a complex bag. So feedstocks is a big issue. Is with the chemical industry, a lot of our feedstocks have carbon within them. So getting a sustainable route for our feedstocks is key. So decarbonizing our energy, and there's lots of different ways of doing that, is important. And then we've got the transport and packaging side as well. So it's a complex environment, and it's technically challenging. So decreasing virgin manufacturing also by reuse and recycling. The less virgin material we need to make, the less that we have to used up potential feedstocks, energy, etc., etc. So the more we can reuse and recycle within our industry, the better. And that's true across all the foundation industries. And I think in terms of chemistry and science, I think there's a lot that we need to, I know there's lots of work going on already, but how do we use greenhouse gases, whether they're pure CO2 or whether they're a mixture of a waste gas stream or a waste effluent stream or a waste solid stream as feedstocks to move to negative greenhouse gas emissions? So how can we move to actually our industry becoming, an industry that takes away some of the greenhouse gas emissions in the atmosphere? Next slide, please. So I was asked to talk about, oh, you've gone on. Next slide up, you've gone too far. That one. I was asked to talk about drivers, barriers and opportunities. So the drivers and barriers for us in the UK chemical industry are really the UK position versus the global position. So carbon leakage. So that's really, most of our products are made globally, so we are really competing on a global scale. So it's easy potentially to think about reducing carbon here by a variety of taxes or et cetera, but we have to be really careful that we just don't offshore the greenhouse gases, because that makes absolutely no difference to greenhouse gas in the atmosphere. Investments, it's I work in a global company, and it's clear that government support for greenhouse gas reduction is more prevalent in different parts of the globe than it is in the UK. People, skills and jobs and desire sort of have linked together. I mean, we have, as I've said, we have over 30% of our site is under 30. I would say that we still need people of a very diverse nature to come and do our jobs. They need to realise, in terms of wider community, how good the jobs are, how interesting they are, how challenging and how well paid they are. And also, I think a desire in the wider community. How do we engage that desire to actually skill and work in the foundation industry, that actually true understanding of what happens inside a foundation industry, rather than what we think's happened or what happened 20 years ago, 30 years ago, etc. And we need a journey plan, and that's what we're working on, and there's policies in place, but we need to do more. Is we can't just move from where we are now to net zero. We need a transition to help us move along that journey, and some of that's carbon capture and storage, some of that's the hydrogen economy, etc., etc. I think opportunities for collaboration across the different work streams of people in terms of skills and jobs, which I talked about before. Technical approaches and solutions with synthesis, particularly at the science level, and digitization. We've done a fair bit of digitization in the chemical industry. There's more to do, and I think some other industries, potentially actually outside the foundation industry, are really good at that, and using technology to really drive productivity. And then, that comment's just popped over my screen there, Mark. So, and byproduct waste stream use, I've talked about that before. How do we actually use some of our waste streams, whether they're gaseous or whether they're aqueous, as raw materials for other processes, or to make our raw materials. Next slide, please. So in terms of research and innovation support, so if I'm not in research, I've been in operations and business for over 30 years, but some thoughts around what I would, as a sort of somebody in the chemical industry, what I would like to understand is in terms of some of the people areas, so skills, so understanding really why we've got some gaps in skills, particularly I would say around the construction trades that support the building of new chemical plants, and what approaches are used to tackle. Society, so as I said before, really did that depth of understanding of the industry, and really the benefits to the local and the UK economy. Even though the Chemical Industry Association and the local industry partners have done a huge amount, I still don't think that's really widely understood, that if we lose these industries, these well-paid jobs that are broad in their supply chain, well-paid jobs as well, we won't get them back. They will be offshored. And really that's the esteem of the industry. I think in other parts of the world that the esteem of working in manufacturing is a lot higher than it is in the UK. And I think there's a desire that really I'd like to understand why, and really what is that desire to support across all partners, whether that's education, government, unions. What is it around that joint understanding of really working in our industry and actually making it a thriving industry for the future as well as today? And then technical, some areas, you know, we've got greenhouse gases, they contain carbon, so we need carbon. So I think the chemical industry would like to understand what are the potential routes, programs, potential pathways, synthesis of chemicals using waste, so technical solutions and sharing of best practices, and then digitization approaches in the foundation industry, so best practice sharing, global comparisons, other industry comparisons would be great as well. Next slide, please. I think that's me finished. Yeah. Hope that was helpful.
Brilliant. It certainly was, Melanie. Melanie, thank you very much. Thank you. And I apologize. I think I struggled to get the slides through the children that have all come home from school and switched on their Nintendo Switches. So apologies for the slight delay. But to complete the speakers for the session, I would like to introduce Karen Finney from the National Translational Energy Research Centre to tell us about her work on bio-waste utilisation for energy and materials. There we go.
Can you hear me?
Yeah.
Yeah, okay, great, yeah. So yeah, I'm Karen Finney, and I work at our brand new shiny facilities at the University of Sheffield called the Translational Energy Research Centre. And so yeah, I'm just going to tell you a little bit about the Translational Energy Research Centre, and then looking at bio-waste utilisation for the co-recovery of both energy and materials. So next slide, please. Thank you. So yeah, this is our nice new national pilot scale facility, the Translational Energy Research Centre, which we call TERC. And this is our new centre to demonstrate green energy solutions to ensure that the future energy system is secure, affordable and sustainable. It's a £21 million facility that was part funded by the UK government, so BEIS, and also the European Regional Development Fund. It's one of the largest and best equipped facilities in Europe for research and development of a wide variety of energy technologies. So zero carbon energy, hydrogen, bioenergy, carbon capture, and that with utilisation and or storage, and also combustion. So we're looking at developing technology, so progressing them from a technology readiness level of sort of 3 to 6, and enhancing those so that they're closer to commercialisation. We are a global leader in net zero innovation, so looking at fundamental research and applied research into resilient energy technologies. So looking at providing cleaner solutions for today, but also a wider range of options for tomorrow as well. Next slide, please. So our new centre is quite commercially focused in terms of the research, development and innovation that we do. So yeah, if you click through. So we work with global companies of all sizes, so from technology startups to multinational corporations. We also work with other academic research teams, so UK and UK universities, but also universities from all over the world who would find benefit from using our testing facilities. We also work with other world-leading research and innovation centres, and then the last click, so should be regional enterprises, so particularly working with local SMEs. Okay, next one, please. So as I already said, we have quite a broad research remit in terms of the things that we look at. So there's a lot of things that we do that won't be directly relevant to today, but the things that I will be talking about include bioenergy. So this is looking at both your nice clean virgin biomasses, but also bio-waste materials. Also looking at themes around energy efficiency and resource efficiency, and process integration as well. So they're the themes I'm going to focus on today, but we do look at quite a broad range of various other low carbon and zero carbon options. Next one, please. Okay, so now I'm going to focus a little bit more on the sort of the co-recovery of energy and materials from the utilisation of bio-waste at our facilities. So next one, please. As I said, we've got quite a lot of activities at TEC. So looking at energy recovery from a wide range of fuel sources. So we tend to focus on what we would term sort of industrial relevant, mainly solid bio-based fuels. So as you can see, chips or pellets. We do use the sort of the nice virgin woods, but we also look at quite a wide variety of what we would call lower quality biomaterials, so mainly bio-wastes. We also have options to look at both liquid and gas fuels as well, that we would look at sort of bio-resources. So things like biodiesel, as well as syngas or biogas. And we're very interested in enhancing the overall process efficiency, looking at process optimization and process intensification and integration as well. Exploring the symbiotic relationships between the resources that we're using or the potential resources that we're generating and the energy recovery from these as well. And so looking at that kind of ties into the recovery of residues or product streams or feedstocks, however you want to term it. But looking at sort of maximising the recovery of these and the utilisation of these different options. So next slide, please. So we have a wide variety of equipment at our research centre. So the ones that particularly be of interest to this audience would be our combustion and gasification facilities. So these are both biomass, bio-waste facilities where we export the electricity that we generate to the grid, and then we also have integrated thermal energy recovery as well. We have extensive online analytical facilities, so we can do comprehensive analysis of the processes. So looking at kind of, your standard temperature, pressures, flow rates, and flue gas analysis, as well as looking at kind of other things that might be more particular to ourselves. So things like combustion generated metal aerosol emissions and submicron particulates. We also have a lot of expertise and experience in modelling and simulation software. So looking for systems validation. So we can test, optimize and demonstrate a wide range of technologies at scale. So prior to their sort of larger scale commercial deployment. And so we're in a good position to provide commercially focused research, mission orientated research, and to sort of de-risk the innovation and investment for these future technologies, and looking at a flexibility and optionality driven approach. And next slide, please. So yeah, a little bit about one of our facilities in particular. So this is our moving grate fired boiler. It has integrated waste to energy capabilities and is also fully integrated with our carbon capture plants on site as well. So it's almost a quarter of a megawatt, and it's specifically designed for research purposes. So I don't have my pointer, but there's 5 sort of black circles sort of in the middle at the bottom. So these are research ports, so we can have probes and look at what is happening within inside our combustion chamber and flue gas pathway. So this might be things like flame imaging or in-flame gas sampling and various other things as well we can do. And next slide, please. So because we are looking at things like waste, we have high combustion temperatures and make sure we have sufficiently long residence times of the gas. So we generate as cleaner flue gas as we can, and ensure that we are compliant with the Medium Combustion Plant Directive. So this does have quite strict emissions limits. So as I said, we've got quite a wide range of fuel capabilities on this facility. So everything from virgin biomass fuels through a whole wide range of different sort of wastes or residues. So from agriculture, forestry, recycled wood products, and then things like vegetable waste as well from food processing. So it can have a wide range of different either pelleted or chipped fuels. Next one, please. So in terms of looking at materials recovery from this, so you can generate different residues or product streams. And so particularly from biomass or bio-waste, we'll be looking at various grades or sizes of ash. So depending on what biomass you're using, as well as the combustion process or combustion technique that you use, your composition and properties of your ash can vary quite widely, and this also varies quite a lot on whereabouts in your process you're collecting it. And so in the great boiler that I just showed, we collect 3 different ash streams. So we have the coarse bottom ash from underneath the grate, and this will have very different composition and properties to the fly ash that we would recover. And so we have multi-cyclone system to collect the finer ash, and then the very fine ash would be collected in our electrostatic precipitator. And so all of these ash streams can be collected to be used in a subsequent process. So if you click again. Excellent. So this is kind of looking at all of the different biomass ash utilisation options that are available. So there's a variety of just different industries and industrial sectors that could use either the ash as it is, or for the extraction of higher value components. And so, this does relate to the paper industry and chemicals industry here. So there's a lot of different uses that I've outlined. And as I said, the different fractions would have different uses. So if you were looking at something maybe like insulation or aggregates, you want to be using the bulk of the ash. So you want the coarser ash would be more useful for this kind of application. If you're looking at things like extracting specific metals, you'll probably be more interested in the fly ash product streams that we'll be generating. Particularly for biomass, we call it has a higher ash enrichment factor than other fuels. So this means that the metals are preferentially concentrated in these smaller particles. And so these streams would be far more useful for things like the extraction of metals. Next slide, please. So the other kind of materials recovery we can do is through carbon capture. And we have various technologies on site to generate high purity CO2 streams. So we've got 3 different facilities. So the one you can see in the photo here is our fully instrumented, what we would call our conventional solvent-based capture system. And we also have next generation process intensified solvent-based system, which is a rotating pipe bed. And then our third one is a next generation molten carbonate fuel cell. And this can capture CO2 as well as producing electricity simultaneously. Okay, so the next one, please. So, if you're generating a high purity CO2 stream, again, there can be a wide variety of uses for this in a wide variety of industries. Obviously permanent storage, removing the CO2 from the carbon cycle would ensure a net reduction in emissions. But in terms of the utilisation, they don't always guarantee or equate to a reduction in the net emissions, and that's something that's really important to note. But if we are using the CO2 to form things like aggregates or using CO2 for mineralization, these pathways where we are using the CO2 but for a sort of more permanent removal of it from the system, then we can achieve net negative emissions through this. Obviously, if you're using something like synthetic fuels, if that fuel is going to be then used in transport or something, then the CO2 will be put back to the atmosphere, so you won't necessarily get a net reduction in emissions. But a lot of these different utilisation options can lower your net CO2 emissions. Okay, next slide. So yeah, now just to sort of summarise the facilities. So we are specialists in bioenergy and bio-waste utilisation, and we can use a wide variety of different fuels on site with our different combustion and gasification systems. We can fully characterise those processes with our wide variety of analytical probes and flue gas analysis systems. And more importantly for here, we can have significant ash recovery. So the bulk coarse bottom ash all the way through our system to our fly ash in our fly ash collection devices to enable subsequent processing of these. All of our facilities are integrated with our carbon capture options, so we can generate our high purity CO2 product streams as well. And something that's really important to mention here is we do have visiting bays. So there's, you can probably just about see it, there's like a yellow sort of, I think it's a HIAB parked in the space in our yard. This is one of our visiting bays. This means that anybody can bring in their equipment and integrate it into our facilities. It's a plug and play system, so each of the bays is fully equipped with water, electricity. It's fully integrated into our flue gas loop and our cooling loop as well. So it's a plug and play system that we can integrate other people's facilities into ours, so you can test what your system's actually going to do if you get CO2 from an actual carbon capture system, for example, from one of our composters on site. Next slide, please. Okay, so yeah, just sort of speaking more broadly, so about supporting industry and enabling collaboration. So the things that we would be interested in working on be things like projects that are looking at enhancing the process efficiency, process integration and process intensification, looking at maximising the recovery and utilisation of materials and improving the efficiency of resource use, and making sure that the feedstocks are secured, so the biomass that's coming in is secured in a sustainable, environmentally friendly manner, but also the feedstocks that we would be producing, so our product outputs, our ash and our CO2 are also used in a sustainable way, and managing waste materials to make sure that we are avoiding sending things that are inherently valuable if we think about it, and make sure that these are not going to landfill. We can also offer integration of any plant that is brought into our low grade or waste heat recovery system. We can make sure that we're looking at the efficient interaction of the energy sector with other industries, so minimising CO2 emissions, so scope 1, 2 and 3 from these. We can also offer advanced process simulations and whole system modelling, as well as computational fluid dynamics to aid complementary system validation. So although our group doesn't specifically do this, we do have many other links throughout the university to other research groups and departments that are looking at complementary research. So looking at things like life cycle analysis, environmental impact assessments, supply chain analysis as well, and other technical aspects of the circular economy. I think the next one is my last slide, just to say, yeah, thank you for listening. Yeah, I'll be here for questions, and our email, website and Twitter account are there if you want the information.
Brilliant, wonderful, thank you so much. And I'd just like to take this opportunity to say thank you to all our speakers today. That's been absolutely wonderful, and has really got some thought-provoking ideas already going through my head, and certainly going through our audience's head by the looks of some of the questions that have come through. Now, we do have a little time for questions, which is fantastic. And I know that some of the questions have already been answered in the chat. So if I don't particularly go through to every single question, that's because maybe some of them have been answered or covered elsewhere. The question I'd like to start with, though, and it was a question from Katie Lamb from Sheffield University, and James Marshall did kind of cover this a little bit in his presentation, but it was a question to Mark Broomfield. And it was I'm going to paraphrase a question just to put it in context of James's presentation. Is this idea of a paper mill and the waste from the paper mill being used on site to remake chemicals and chemical building blocks? Do you think that's something that the paper industry would take on board and move forward with, or would it be simply a use of your waste becoming a feeding stock for another industry?
Well, short term, that's what we've been trying to do. I mean, it's very, and you're aware of this as well, Graham, that using our waste feedstocks in other industries are located around the country. But I do think there's an opportunity when we're really trying to transform to make it more of a collaborative approach with the similar facilities on site where you can use those waste streams. I think that's the kind of, not just the waste streams, there's waste heat, there's water, there's a lot of opportunities when you try and integrate more between industries and rather than operate in separate silos. So for now, we'll move them, but future, can we use them locally?
Brilliant, thanks, Mark. And really, just to follow up on that a little bit, is maybe outside the chemical industry and thinking about some of the work that I do around the construction industry, and do you feel that there's a real step change that can be had in upscaling and valorizing the waste from your factory?
There's a definite desire to do it. I think for years our primary goal, as many other industries, was stay out of landfill, and now it's moved on. Now we've moved on. It's whole environmental impacts. It's sustainable. It's value from those waste streams. So there's a definite shift in focus from, traditionally we've just focused on our core business, making product. Now we're looking at the incoming raw materials, the outgoing wastes. Who can we partner with? How do we get value from those? How do we reduce the environmental impact? How do we make them more sustainable? That's 4 or 5 years ago, we weren't focusing on that. It was just all about paper. Now it's about the outputs.
Yeah, brilliant. Thanks, Mark. James, I'd like to pick up on a question. I know you did answer it with a resounding yes in the chat, but I'd like to just pick up on a question from Jeff around the idea of your process is amazing, and I've followed it for a long time. But the waste streams are changing, and they're changing vastly, and a lot less is going into black bag waste, as it were. How do you see this affecting your business model and the way that your business will work in the future?
Can you hear me okay?
Yeah, fantastic.
Yeah, as I was trying to allude to on the response, was a bit rude of me actually replying on the chat when there was other presentation goes, so apologies for that. But yeah, there are going to be big variations in terms of the waste nature that's in the black bag. There's also going to be changes in terms of the way that the MRF structure is set up to do with deposit return schemes. So the same question can be applied to plastics and that feedstock as it can do to the paper side. But what we have seen from the work that we do, that as long as you look at the both or all fractions of the mixed feedstock, rather than concentrating on uplifting one particular part of it, then you're able to create a lot of homogeneous opportunities, a lot of homogeneous feedstocks from what is a very mixed input. And at the tonnages that a single train fibrite facility will be able to accept, those variations can be smoothed out with pure dilution. So what I was trying to say on the email is, sorry, on the chat, is the work we've done on some of the longer fiber material over in the States, where they have a lot more virgin paper entering the packaging system compared to here in the UK, where we've got a lot more recycled with shorter length fibers, is to make sure that we've got the cleaning process, the extraction process, and then the uplift washing process to make sure that what pulp we produce is more about yield in terms of volume of pulp in the feedstock rather than quality of the cellulosic fraction that we can recover. And we get very consistent cellulose, which therefore means that we can get very consistent sugars. So still a lot of work to be done, but the changes in composition are to be expected, and those changes are going to drive the wider resource recovery and recycling rate opinions. The aim of Fibre is to make sure that we can absorb those changes and ride those fluctuations. Hopefully that answers the question.
It does very much, James. Thank you very much. Thank you. There's a question here for Melanie, really, and it's quite an esoterical question, I think, but what do you consider the chemical sector's attitude towards this whole idea of dematerialization of society as a way to achieve net zero 2050 targets? I mean,
as in, when you talk about dematerialization, you mean so people aren't using materials in their normal lives?
Yeah.
Is that what you mean?
Yeah, and they don't consume.
Well, Mike Lancaster's here from the Chemical Industry Association, so maybe Mike can answer that one if he's not switched off. I can't answer on behalf of the chemical industry. I would say that what we aim to do is make things lighter, and more so in that way. But I don't think that we've got a policy in terms of dematerialization in the chemical industry, as in we've got net zero, et cetera, et cetera. It's a very tough question to ask somebody.
Yeah, is it perhaps this is coming from maybe a seat of slight knowledge, but is in fact for looking for other opportunities for the same materials that you're making?
How does that dematerialize, though?
It takes away the use of materials in throwaway society. So it's one part of dematerialization, and then can make something that lasts a lot longer, so you don't have to replace it so often.
Yeah, I think that's a societal issue, isn't it? The disposable economy, and I don't think that's just really a chemical industry issue, is it? Is if you buy a washing machine, you want to be able to run it and repair it and look after it, not have to just throw it away with all the different component parts that are in it that come from the steel industry, from the chemical industry, from the electronics industry. In terms of the business that I'm in, we're not in single-use plastics, so we're in long-term plastic use. So it's acrylic, so it goes into acrylic baths, etc. And we are working on, and there is a technical recycling route that will recycle acrylic back to its monomer, not just the plastics recycling. So you can actually take it back to its virgin material. So we, as the industry leader, we're investing in that in terms. So that piece allows you to recycle. But in terms of dematerialization, I think you probably the chemical industry is so wide. It's you're talking about huge. You're not just talking about plastics. You're talking about chemicals that go into healthcare, that go into sanitary products. It touches every part of society. So that's quite a tough question to ask the chemical industry. It's not really just like the paper industry. The products are everywhere. So it's everything that we use is touched by the chemical industry. So I think that's a societal dematerialization.
Mike Lancaster, I did see your mic come on and then go off again.
Did he? Good. Oh, come on, Mike.
I wasn't sure I could control my mute button. There's certainly a growing interest in chemical leasing, and you're selling a service of which a chemical is part of it, but then taking that material back and recycling and reusing. I think, as Melanie said, the durability aspect is largely in the hands of the people who make the final product for the consumers, which isn't the chemical industry. The chemicals are durable and inherently recyclable.
Yeah, that's brilliant.
Selling mass volume, but selling a valuable service.
Yeah.
Brilliant. Thank you for that. we are coming up very much to our final 2 minutes, and I know we're going to get kicked out of here quite promptly at past, so that we can all have a break before we reconvene in the plenary session. So I am going to thank you to everybody who gave questions, and I apologise if I did miss any that weren't answered in the chat. I do apologise for that. Once again, thank you very much for all our 4 speakers today. It's been a real pleasure to listen to you, and I'm going to just in case, yep, I'm going to now bring this session to a close. The plenary session starts at 4:40, and you will be back in the main room. So thank you very much. Thank you very much to all our listeners and our participants. And again, one last thing and one last time, say thank you to our speakers. So goodbye from me and goodbye from everyone. Thank you.